Theorem 7.1, which is also known as the ASA congruence rule. Theorem 7.1 states that two triangles are congruent if two angles and the included side of one triangle are equal to two angles and the included side of another triangle. So we are given two triangles ABC and DEF, in which we have angle B equal to angle E, angle C is equal to angle F, and the included side BC is equal to EF. This information is given to us. We need to prove that triangle ABC is congruent to triangle DEF. Now let us understand the proof. We will have to use previously established result, which in this case is our SAS criteria. And for that we need two pair of corresponding sides to be equal and one pair of included angle equal. Now if we see here in this case, we have BC is equal to EF and we have angle B is equal to angle E. So let us take this side AB and DE. Let us consider AB and DE. But if we are taking AB and DE, we must understand that no information is given to us about this side AB and DE, whether they are equal or not. So in this case, for proving the congruency of these two triangles, there are three cases which arise. Case 1 is where AB is equal to DE. Case 2 is where AB is greater than DE. So we have to visualize something like this, that DE is little smaller than AB. So triangle DEF is little smaller. And case 3 is where AB is less than DE. So then this triangle ABC is little smaller than triangle DEF. Now let us see in all these three cases if we can prove that the two triangles are congruent or not. Let us understand. Case 1, where AB is equal to DE. So we are assuming that AB is equal to DE. Then proving them congruent is very easy. Since we have assumed that AB is equal to DE, that is my first argument. Okay, AB is equal to DE. Then angle B is equal to angle E. It's already given. And BC is equal to EF. That is also given. And so if you can see by SAS criteria, I can say that triangle ABC is congruent to triangle DEF. Now, the second case, where we are assuming that AB is greater than DE. Now, if AB is greater, then I can put a point somewhere here, and we will call that point P, such that PB is equal to DE. Okay, so we can put a point P on AB such that PB is equal to DE. And now we are going to consider triangles PBC and DEF, the green triangles, PBC and DEF. Here, so look here at the bottom now. Observe that PB is equal to DE. By our construction, we have constructed P. So by our construction, we have constructed PB, which is equal to DE. Angle B is equal to angle E. That is already given to us. And BC is equal to EF. That is also given. And again, by SAS, I am proving that triangle PBC, the green triangle PBC, is congruent to triangle DEF. Okay? Using the SAS axiom of congruency. Now, since these two triangles are congruent, the green ones, the rest of the corresponding angles also become equal. And so we can say that angle PCB, that means this angle, is equal to angle DFE, that means this angle. Okay, but it is given in our statement that angle ACB is equal to angle DFE. ACB, this big angle ACB, is equal to angle DFE. It was given in the theorem statement. Since PCB is equal to angle DFE and angle ACB is equal to angle DFE, we can say that these two angles are also equal. So we conclude that ACB is equal to PCB. Now look here, ACB is this angle, ACB. How can that be equal to PCB? PCB is little smaller angle. But according to our assumption and logical arguments, we come to this conclusion that angle ACB is equal to angle PCB. Now that is only possible if P coincides with A. That means P and A are actually the same points. They are not different points. And so we had constructed PB such that PB is equal to DE. But now that P and A are the same points, we can say that AB is equal to DE. If AB is equal to DE, then it turns into case 1. So AB is equal to DE, angle B is equal to angle E, and BC is equal to EF. And so by SAS, we can say that triangle ABC is congruent to DEF. Now, the third case, where we assume that AB is less than DE. Now here in this case, DE is bigger. And so we will take a point on DE here. Let us take a point M such that ME is equal to AB. ME is equal to AB. And now we are going to take two triangles ABC and MEF as we took in case 2. So here we are considering by our construction that AB is equal to ME. Also, it is given that angle B is equal to angle E. And it is also given that BC is equal to EF. And so by SAS criteria, we are proving that triangle ABC is congruent to MEF. The green triangles are congruent. Now, if they are congruent, then the other corresponding angle are also equal. Then we will have angle ACB equal to angle MFE, right? But it is given to us that angle ACB is equal to angle DFE. ACB is equal to angle DFE, the DFE. So if you see here, ACB is equal to MFE and angle ACB is equal to DFE, then we can conclude that angle MFE is equal to angle DFE. So now think about it. Can DFE angle be equal to MFE? This can only be true if M coincides with D. That means M and D are the same points. They are not different points. And if they are same points, remember we had constructed ME such that ME should be equal to AB. But now since M and D are the same points, we will have AB is equal to DE. And now if AB is equal to DE, again we come to case 1. It is same as case 1 and we can say that triangle ABC is congruent to triangle DEF. So I hope you are understanding. Case 2 and 3 turns into case 1. And so in each of these cases, we are getting triangle ABC equal to triangle DEF. Now in case 3, you don't need to write everything again. You will just write if AB is less than DE, we can choose a point M such that ME is equal to AB. And thus, by repeating the arguments as given in case 2, we can conclude that AB will be equal to DE. And so since M and D are going to be the same points, AB is going to be equal to DE. And that will bring us to case 1. And so we will prove that ABC is congruent to DEF. So writing this much is enough.